All right, I'm going to look at some of the integrals from the review, try to get as many of these done as I can. The first integral is the integral of tangent of 2x. I think this is problem number 10 on your sheet. Big thing is you need to make sure that you have the integral functions memorized for trig functions. So not only sine and cosine, but also tangent, secant, and so on. Remember that the integral of the tangent function is actually related to the derivative. Remember, the derivative is secant squared. The integral is a natural log of secant. Also remember the chain rule. You need a derivative of 2. You don't have that 2, so you can multiply a 2 in, balance it with a 1/2. So when you reverse the chain rule, the 2 dx goes away. You're going to get 1/2. Remember, it's an ln of a secant of the inside function. You've got an absolute value there, plus c. Okay? So again, mostly memorizing, but you do have to remember the chain rule. Okay? Problem number 11 is the integral of the secant of 1/4 x dx. Same kind of thing. You need to know the integral of the secant function. Remember, derivative of secant is secant x tangent x. The integral is the natural log of secant of x plus tangent of x. Derivative of the inside function is 1/4. You need to balance it with the reciprocal outside, which is actually a 4. So that'll be 4 ln of the absolute value of secant of 1/4 x plus tangent of 1/4 x. Inside function never changes. And you have a plus c, and that's what's going on there. Okay? Moving on to the next one. It's the integral of secant squared of 6x dx. And I think this is problem number 12. The derivative of the inside function is 6. So you need a 6. You don't have a 6 out in front. Multiply a 6 in. Balance it with the 1/6 on the other side. Notice secant squared is the derivative of the tangent function. So the chain rule knocks out the 6. It just ends up being 1/6 tangent of 6x. And remember also to put your plus c there when you take an indefinite integral. Okay? Moving on to the next one. Next one is the integral of x e to the 2x dx. Anytime you see a product, especially on the ABAP exam, keep in mind that it probably has something to do with the chain rule. So I always check the inside function and I try to see if there's any kind of connection. But if you notice, the derivative of the inside function here is 2, and we have an x here. So this is a case where the x is not being multiplied because it's the derivative of an inside function. This is a great example of a case where you may want to use integration by parts. Okay, you've got a u, you've got a dv. I usually try to make my x the u because it gets simpler when I take the derivative. I've got my e to the 2x over here. My du value is going to end up being 1. Derivative of x is just 1. My v value here is the antiderivative of my dv. That's going to be 1/2 e to the 2x. So remember, the formula is it's u times v minus the integral of v times du. U times v is x times 1/2 e to the 2x. I usually write that as 1/2 x e to the 2x minus the integral of v times du, which is going to be minus that integral. So it's the integral of e to the 2x, which means I do need to integrate again. So I get 1/2 x e to the 2x minus, because of the derivative of the inside function, I need a 2. I need to balance that on the outside with a 1/2. 1/2 times 1/2 is 1/4 e to the 2x. And don't forget your plus c, and you've got your solution there. Okay? So a little bit of integration by parts if you've forgotten how that works. All right? Next one here, we have the integral of 2x sine of x. Again, the derivative of the inside function doesn't have anything to do with that. This is going to be another example of integration by parts. Once again, I'll put the 2x on this side. I'll put the sine of x here. The derivative of 2x is 2. The antiderivative of sine, be careful, it's negative cosine of x. And so the formula says to take u times v, which is going to be negative 2x cosine of x, and then subtract the integral of v times du, which is going to be negative 2 cosine of x, technically dx. I would probably take out the minus and negative there and just make that a plus. I think it'll simplify things down a little bit. And I get negative 2x cosine of x plus 2 sine of x when I take the integral. And again, don't forget your plus c, all right? So continuing here, we move on to problem number 15. 15, pretty straightforward. It's the integral of 3e to the 5x dx. And this one, the derivative of the inside function is 5. I don't have a 5. You may want to factor the 3 out. Remember, you can bring a constant out in front. I need a 5, don't have one, which means I need to balance it with a 1/5 out in front. And that's going to give me a 3/5 e to the 5x plus c as my final integral there. The next question, which on my sheet is number 16, is the integral of the natural log function. You can memorize this, or you can use a little trick to use integration by parts. You can break this up as 1 times the natural log function. And I'm going to put 1 here because I know how to take the integral of that, and I'm going to put natural log on this side because I know how to take the derivative. The derivative is 1 over x, the antiderivative is x. So integration by parts says I take the product of u times v, so that's going to be x times the ln of x, minus the integral of b times du. Well, notice, that's going to give me x over x, which is just 1. So I'm just taking the integral of 1, and that's going to be x ln of x minus x, and don't forget your plus c. So if you want to remember that the integral of ln of x is just x ln of x minus x, that's great. If you want to go through integration by parts, it also works out pretty nicely. Okay? Continuing with this, let's look at 17 and 18. 17 gives me the square root of 3x minus 8. You don't want to keep a square root as a square root. You want to change it to a 1/2 power. Okay? Notice I have an inside function here. The derivative is 3. I don't have a 3, so I multiply in a 3, balance it with a 1/3. And then I just go through the process here. Inside function does not change. The power raises to 3/2. You're going to divide by that new power, but remember that dividing by 3/2 is actually the same thing as multiplying by the reciprocal, multiplying by 2/3. And then I had this 1/3 out in front already. 1 times 2 is 2, 3 times 3 is 9. We get 3x minus 8 to the 3/2. Again, you never want to forget your plus c. All right, so there that is. Question 18. It's an integral of 5 over x squared. We don't have a quotient rule for integrals, so the way you probably want to handle this is to rewrite this as the integral of 5x to the negative 2, and this is just a power rule. Raise the power by 1, be careful, negative 2 plus 1 is negative 1, and so you're going to get 5x to the negative 1, divide by the new power, add c. You could write that as negative 5x to the negative 1. You could also write that as negative 5 over x. You could drop that x to the negative 1 to the denominator, or write that as x to the negative 1. Obviously, on the multiple choice part of the AP exam, you're going to have to go with whatever they give you in the multiple choice options. All right, moving along to 19. 19 is the integral of 2e to the x over e to the x minus 4 dx. Notice something here. The derivative of the denominator is very similar to the numerator. That's a case where you can probably write this as a reciprocal function. I'm going to factor the 2 out because it doesn't really have anything to do with anything. I'm going to write that as 1 over e to the x minus 4. And the derivative of the inside function is e to the x. So I'm going to bring that out here. I'll reverse the chain rule. Derivative of the inside function was there, and it's going to go away now when I reverse the chain rule. And it's the integral of a reciprocal function. So it's just going to be the natural log of that denominator. I have a plus c, and remember I had 2 being multiplied out front. So we're going to get something that looks kind of like that. Okay, next problem. It's the integral of 2x squared plus x minus 15 all over x plus 3 dx. Every once in a while you get lucky and you get something that factors. And this one I believe is going to factor. I think you're going to get the quantity 2x plus 3 times the quantity, I think it's going to be minus 5. I'm thinking the x plus 3 is going to cancel. So I'm going to try it with an x plus 3 here and an x plus 3 in the bottom. And we get a negative 15 when we multiply there. You get a 6x, you get a negative 5x. That should work out. and this is going to cancel. Gives me just the integral of 2x minus 5 dx. Don't forget to take the integral once you simplify. Raise your power by 1, divide by that new power, leaves you with just x squared. You're going to minus 5x, and then you've got a plus c. So again, if things factor, you could also use synthetic division there, and you could probably also get it to simplify the same way. Speaking of synthetic division, oh, we're a couple problems away from that one. It's coming though. Question 21 was the integral of 4x squared minus 5x plus 6 all over x. I can't stress it enough. Don't forget algebra 1, okay? Everything is being divided by x here. So that's really just going to simplify to 4x minus 5 plus, it would be just 6 divided by x. I don't have an x to cancel. And then dx. And so again, integrate. Going to raise the power by 1, divide by the new power, get 2x squared, minus 5x, and that's 6 times 1 over x. The integral of 1 over x is really just the natural log of the absolute value of x. So it's going to be 6 ln of the absolute value of x plus c, and you have your solution there. So that kind of thing can be very helpful. Okay. Moving on to the next one, this is 22. It's the integral of 2x minus 5 over x squared minus 5x. Once again, I notice it's a fraction. I don't have a quotient rule for integrals, but if I happen to see that the numerator is either the denominator's derivative or something close to the denominator's derivative, I could probably treat this as a reciprocal function, and that's what's going to happen in this case. So I'm going to write this as 1 over x squared minus 5x. That is the derivative of the inside function, so that's going to allow me to reverse the chain rule here. The derivative of the inside function goes away. The integral of a reciprocal function, as long as your denominator's power is just 1, it's the absolute value of x squared minus 5x. And again, don't forget your plus c. Okay? Continuing down the stretch run here. Problem 23 is x squared plus 7x minus 2 all over x minus 1 dx. I don't think that's going to factor. You can toy around with it. You can try. I don't think it's going to factor, though. So I'm going to use synthetic division here. I'll use a 1, a 7, and a negative 2. Bring down by 1. 1 times 1 is 1. Add. We get 8. 1 times 8 is 8. We add, we get 6. That's a remainder. That's a constant. That's an x. Okay, it should drop from an x squared down to just an x. And so when we divide, I end up with x plus 8. With the remainder of 6, my divisor is x minus 1, so it's plus 6 over x minus 1. Okay, and then we just take the integral of this. That integral is going to be x squared. That integral is going to be 8x. That's 6 times 1 over x minus 1, which is just 6 times the natural log of the absolute value of x minus 1. So keep in mind, synthetic division can occasionally give you something that makes for an integral that's really not all that bad. Okay? Continuing, trying a few more here. 24, we want to find the integral of cosine cubed of x dx. Remember, your odd powers of sine and cosine, you can use the fact that the sine squared of x plus the cosine squared of x is equal to 1. In this case, I'm going to break this up. I'm going to hold out as cosine, and I'm going to rewrite this as a cosine squared of x times a cosine of x dx. And I'm going to keep that as the derivative of my inside function. I'm going to convert this over to sines. So cosine squared of x is just going to be equal to 1 minus sine squared of x. Okay? And so I'm going to replace the cosine squared of x with 1 minus sine squared. And what that's going to do here is it's going to give me a 1 minus sine squared of x. That whole thing is being multiplied by the cosine of x on the outside. And so that gets distributed. I'm going to get an integral of cosine of x, which is really easy. And I'm going to get minus sine squared of x cosine of x. Remember, that really means sine of x quantity squared. The integral of cosine of x, of course, is just sine of x. And that's the derivative of the inside function. So that's going to go away when I take my integral along with the dx. And really, I'm just raising the power by 1, dividing by the new power. So that's going to be minus sine of x to the third over 3, or I could write that as 1/3 sine cubed of x And you've got your plus c, and you're done. Not too bad. The next example here is related, but not the same. It's an even power of sine. It's sine squared of 2x dx. This time I can't hold a sine out because I would only have a sine left and I don't have a sine squared. I need even powers to be able to do what I did in the last one. So I can use the fact that the sine squared of x is equal to 1/2 minus 1/2 cosine of 2x. It comes from a double angle identity. Remember that cosine squared of x is just equal to 1/2 plus 1/2 cosine of 2x. And so I can just replace sine squared with that. Notice I do have to double whatever the inside function is when I make that change. Okay? So this is going to be the integral of 1/2 minus 1/2 cosine, not sine, of twice the inside function. And I just need to take the integral. So that's going to be 1/2 x. Derivative of the inside function is 4. I'm going to need to balance with a 1/4 on the outside. The integral of cosine is sine, so it's going to be minus sine of 4x. We're going to have a 1/8 out in front, and then you have your plus c. Okay, so that's all that's going on there.